Hello everyone, today I'll show you how you can generate automatically detailed sidewalks along your buildings. So here is a generated sidewalk. It has some details on the ground like cracks, some grass growing next to the building and next to these tree planters, street lamps, traffic signs at the corners. There's bike stands and all kind of details. So it really looks not procedurally generated, but it looks like you handcrafted the model, and it's completely dynamic based on the parameters for your building. So if you increase or decrease the size of the building, it will auto-generate the sidewalk along the building. Let's first start with generating it without the integration with the PCG building, so you can understand how it works. And if you don't have this PCG building graph built from the previous tutorials, you can just use the sidewalk as a separate element. I will be creating it later as a subgraph and integrating it with the building. So let me first show you how you can do it as a separate object, and then we'll continue with integrating it with the building. So here I have a separate blueprint, only the subgraph with the generation for the sidewalk. So let's connect the subgraph so you can see how it works. I have it 2 times in the scene, so let me delete everything except this one. Okay. So this is a separate blueprint now, and it generates this sidewalk on a fixed size for the width and the length of this city block. First, let's do the generation like this, and then we'll integrate it completely, integrate it with the building, so you don't have to manually enter the sizes. But it will be easier to understand if we start that way, so we'll skip a lot of the calculations until you understand how all the elements are placed. So let's delete this for now. Let's delete all the decal actors that are generated as well. Okay, so let's start with the new one. So let's add a folder to make it a little bit easier to track. So PCG sidewalk. Let's start with creating the blueprint. So right click, choose a blueprint class, create the blueprint of type actor to be placed in the scene. So call it BP sidewalk tutorial. Inside this blueprint, let's create a PCG component. So add a component, type PCG. Into this component we need to connect PCG graph into the graph node here. So right click into your content browser, create a PCG graph, call it PCG sidewalk. Let's connect it to the graph variable here into your blueprint, compile and save. Into this PCG node, let's do a create points node. This will create the 4 points we need to create our sidewalk. So later I'll show you how to use the points from some other graph. For now we'll just use a create points node, so it's easier to understand how the sidewalk generation works, and later we'll do all the calculations needed to connect it to another graph. So this create points node needs to have 4 points, so add 3 elements into the node. It starts with 1, so you need 3 more. And into the transform for each of the points at offsets to the location. So let's do 20 meters, for example, sidewalk in all directions. So the first point will be 20 and then 2 zeros because it's in centimeters, so 2000 in the x direction. For the second point transform, we need 2000 into the x and y directions. And for the last point, we need 2000 only in the y direction. After we create these 4 points, let's do a create spline node. This will create a spline between these 4 points. Let's do a closed loop and linear spline. So let's save this node and let's place this blueprint inside the scene. Let's debug this spline, and you can see it generates the 4 points and splines between them. So after this create spline, let's do a spline sampler. This spline sampler, let's do a distance mode, and the distance increment will be the length of the element that you will be placing for the sidewalk. So for me, that's 2 meters, 200 units. So let's stop the debug of the create spline and do a debug on the spline sampler. You can see there are no elements in the scene. You have to check this unbounded checkbox in order for your spline to generate elements. And now let's choose into the debug options the absolute method, because otherwise they're generated with a very long bounding boxes. So instead of changing the bounding box, just let's change the debug option to show the constant size of the cube. So these are all the points that we are generating for our spline, and we'll be placing our sidewalk elements along these points. So let's start first with placing the corners. All the elements for the sidewalk are downloaded from Quixel Bridge, so use your Quixel Bridge option here and add the elements that I have. So first let's start with the 4 corners, and this will show you that you need to fix the rotation of this create points element. So let's do a static mesh spawner for our 4 corners, and actually let's do a transform points before the static mesh spawner. So this static mesh spawner, it will have 1 mesh entry into the descriptor, the static mesh. We need to connect our corner piece. So here, let me shrink this window a bit. Here you can see we are generating these 4 corners and placing, let's stop the debug of the spline sampler. So we are placing these 4 corners, but we need to orient them in that way that they are not facing the same direction. So into this create points node, we'll add rotations for our elements. So let's start with the first point with the index 0. Let's start with adding a rotation for the first point of 180. For our second point, let's add rotation of -90. Our third point will be with a rotation of 0, and our last point will be with a rotation of 90. So this is the way the points will come from the building generation script later. So that's why I'm entering these values. You can set up the values that you directly have the proper rotation, but I know that from my other script, this is the rotation that I will get. To fix the orientation of all of this now, so they have consistent orientation, but it needs to be offset in order to have the proper placement. So now this transform point needs to have a value of -90 for all of them. And now they're properly oriented and they need to be moved 400 units into the Y direction. Now we have placed all the corners in the proper orientation and in the proper place for our script to be working fine. And we need to continue with the placement of our sidewalk elements. So first let's continue with placing the curbs. So we are creating the spline and we are using a 200 units distance increment. Let's do a transform points again, and then a static mesh spawner. Static mesh spawner. So this static mesh spawner will again have one element and will connect this curb. It's a modular curb pack from Quixel again. So use your bridge to import this element. And now let me also show you what other I have changed. So this element, I don't remember exactly where the pivot point was originally, but I have edited the mesh by going into the modeling section, then here into the X form, edit pivot, and then click the center. So I'll know that every time I'm manipulating this object, it will be from the center. So it's easier, for example, to rotate or scale it to achieve a little bit of randomization. Because if you have the, for example, here, the pivot point, you cannot use rotation along the z-axis to achieve a randomized look, because it will overlap with the element next to it. But if you rotate it from the center, it will stay in the same place. So that's why I have edited the pivot point to be in the center. I have already set up that. For you, go to the edit pivot, click the center, and then click the apply button. This will edit your pivot. So now into these transform points, you can see it's not starting where the corner piece starts. So let's do an offset. It will be half of the element. So -100. Actually 100. Okay, now it's starting the proper point. And we need to move it -375, I believe. No, a little bit more. 385. Okay, now it's fine. It's a little bit high, but let's move the corner element 3 units up. Okay, now they are better aligning with each other. So now you have a proper placement for all your curb elements, and you need to place the horizontal part of the sidewalk. So I have created this sidewalk element. It's 200 units wide by 370 units long. So go into the modeling section, create a rectangle here at 200 units for the width, 370 for the length, or the opposite maybe. So this 370 and this is 200. Then click here the accept and you have this element created. Then apply the sidewalk tiles material from Quixel. So this also a Quixel material. It's available on the bridge application. So download this material. You'll also need this material as well to achieve some more random look. This is the broken sidewalk tiles. So they are very similar, but one is with the clean tiles and the other one is with the broken ones. We'll use both materials in order to achieve some more realistic look. Let's close these materials. And after you generate this curb part, let's do another transform points. And let's do a static mesh spawner. And let's do a single mesh entry with this sidewalk. Actually, we'll have a second mesh entry here, again with the same sidewalk, but into the override material slot we'll add one material and we'll connect this broken tiles material. So now some of our elements will have the clean tiles, like you can see here. Let me go to the selection mode for a bigger view. So this is the clean tiles and these are the broken ones. So you have random placement of all type of sidewalk material. So it will be much more realistic that way. You will not get this repetition. So let's use this transform points to offset it. So -400. I believe it's too much. It was 370, I believe. -370. Okay, now it looks better. And it's too low. So let's do 14. Okay, 14 units seems fine. And now it's just a little bit offset to the X direction. So let's move it 100 units into the X direction. Okay, now it seems that it fits everywhere fine. So what is important here to note is that currently I have my create points node set up that all the transforms are divisible by 200, which is the size of my element. So if this is not the case, for example, here I have, instead of 2000, I have 2100. Then for the next one, I have again 2100. And here in the last one, I have. So now the size of my sidewalk doesn't match exactly the size of my elements that I'm constructing the sidewalk with. We need to have a calculation that is giving us here the result. So we'll do that later when we connect this PCG graph to our building, because the building size is generated by the number of segments of the walls we set up into the blueprint. So it's dynamic and it changes, and this size needs to be calculated for each side of the building. For now, let's continue with this fixed size of some number that's divisible by 200. So it doesn't need to be 2000. I can have any number that you can divide by 200. So let's just try it with 2800. Let's have for the other direction 2000 or let's say 1200. And into the last one. Okay, so now you see that you can have any size you want as long as it is divisible by the size of your sidewalk element. So for now, let's stick with this type of numbers, and later I'll show you how you can calculate a better way to always have the matching size of the elements. So another thing to note here is that here you can see that sometimes when you generate this spline along all corners, let's disable this corner element. You can see that sometimes when the spline comes here to the corner, the placement of the point, the last point, is overlapping with the corner element. So it's placing this element before it goes around the corner to place the next one, and it overlaps with the corner and sticks out this way. So to avoid this, let's actually use the points that come here and create 4 different splines instead of one full spline along all the elements. This creates spline with the placement of the elements. It will not be just once, we'll create 4 different splines with this. If you click the A key to inspect this create points element, you can see that we get 4 points coming here. If you select the PCG graph, when you have clicked the A key, you can see we have 4 points with the index from 0 to 3. When we are creating the spline, currently we are creating the spline between the first and last point, going through these middle ones, and from the last to the first point we are closing it because we have this closed loop checkbox enabled. To create 4 different splines, let's do an attribute filter. So this filter, let's choose less than or equal. Let's choose here the value to be the index, and let's use a constant threshold and choose 1. So let's now click the A key here for the attribute filter. This will only select the first 2 points of our create points graph, where we have the index equal to 1 or less than 1. So this will be 0 and 1. So let's disconnect this create points with the create spline and use this only this attribute filter. Now you can see that we have a problem, that we have this double-sided sidewalk. This is because our create spline have this closed loop checkbox marked. So let's uncheck it, and now I have the spline starting from the beginning and ending here at the first point. We have again this problem that it's overlapping the corner, but now we know that we'll always have this problem, and we'll just fix it by filtering the last point of our spline here. How we can filter the last point? We'll go here after this spline sampler, and we'll create a attribute select. This attribute select will select the index attribute, will select the maximum index. So this will be the last point that we have into our spline. So if I click here onto the spline sampler, I can see I have points from 0 to 14. And if I click the A key here on the attribute select, you can see that it selects only the 14 value. So now let's do an attribute filter. So this filter will filter by the index element. Let's connect here this one. So it will filter all the points that are less than this value. So not less than equal, but less. So if I click now the A key onto the attribute filter, you can see that the 14th element, the element with the index of 14 is missing, because we are filtering only the elements with smaller index than 14. So now let's connect this insight filter to the generation of this sidewalk elements. So now we created a single spline that goes from the first to the second point, and we are removing the last element here from the spline to not have this overlap problem that we had sometimes before. In order to create the other 3 splines, we need to filter different points. So let's do another filter. So an attribute filter range this time, for example. The attribute filter will filter the index value, and we'll use a constant threshold for both the min and the max, and we'll filter from the integer type of the index from 1, and the max will be again an integer. It will be 2. So now I'll filter these 2 points. So this is the point with the value of 1 here, the closest to the camera, and the one to the far left is with the index of 2. So if I connect now this insight filter to the create spline, it will create the other spline here. Let's do from 2 to 3. Okay, 2 to 3 seems to work fine. And we have the problem here at the end. Okay, so this problem is occurring because now here, when we are trying to filter the last element, you can see I have this warning here. So now the problem is that if I click here A on the spline sampler, it is having 2 sets of points. So I have the point data from the first spline and then from the second spline that we are generating here. And the problem is that this attribute filter cannot filter properly when we have these 2 splines. So first let's do a merge points. Actually first let's do a copy attribute, because after we merge them, then they will have a single index attribute, and we cannot filter 2 points with the single attribute. So we need to first to copy the index value into the some custom index. So let's call it C index, and then let's connect here and let's use this C index into both our filter elements. So let's see now the result. So the spline sampler has 2 sets of points from 0 to 14. Then we are using this copy attribute. We get this C index copied into all the points. So after this copy attribute, we need to merge the points. And we need to connect after them the filtering. So let's inspect now the merge points. Click the A key on the merge points. Now you have only one set of points here. They have index from 0 to 29. All of the points are merged into a single set of points, but we have the custom index from before copied here. So we have the custom index from 0 to 14 for the one of the splines and 0 to 14 for the other. In this attribute select, we are going to get the maximum index, then output again into the custom index attribute. So let's inspect this node, click the A key here, and we have no data available, so we have an error. Input attribute property does not exist. So this merge points, this custom index, not cint, so index. We need to have the proper name here again. Okay, so now it's working fine. This merge points is merging all the points into a single set with 30 points, and we have the custom index saved with this copy attribute for both of the sets. We are selecting the maximum number, so the 14, and we are filtering based on this number only the points before the last one for both of the splines. So now we don't have this overlapping problem on any of our two sides of this sidewalk. So let's continue with the next side. These two sides needs to be together because they are the same length, and the other two sides needs to be separate, because if I use the same logic now and I have here a side of the sidewalk that's only with, for example, 5 elements, this filter, when we are filtering all the points below 14, which is the max index for the longer side, it will return all the 5 points for this side instead of only the 4 that we want to use. So we will have again the same logic here. So we'll copy everything from the spline sampler to the attribute filter. Let's copy it and paste it below. Actually, the create spline as well. Okay, so we copy everything from the copy spline until the attribute filter, and then we'll export both of them. We'll connect both of them here to the transform points that then we are using to place the static meshes. So now let's use the filter, attribute filter range, and this time let's use the min value of 1 and the max value of 2. So now you can see we are properly setting up this side with the proper number of elements, and we don't have this last element. This attribute select filter is properly selecting the last index, which is 6, and then filtering here based on this custom index only the elements with in the custom index less than 6. So now we go to the other side. We are creating a last filter, which will be it's probably faster to use the attribute filter without a range. So for the last points, let's use an attribute filter. We'll get two attribute filters, and we'll get the one equal to 2 and then the one equal to 0. So now if I merge these points, because I need to have a single set going into the create spline. Actually, this index needs to be 3. Okay, so I'm getting the last point, which is with index 3, and then the first point with index 0. Then we are merging them, and then we are creating a spline between them. So now I have created properly this placement of the sidewalk elements along sides that are with different length from each other. So I have a smaller side here into the depth, and into the width I have a longer side, and later we'll use additional calculations that will make sure that we cover all sizes, because now our size needs to be divisible by 200. So that's why we are using this type of numbers that you can properly divide by 200. So let's continue with adding some additional elements so you can see how it is done for the sidewalk. I'll not do all the elements, but just a couple of the types, so you can understand what's the logic behind it and you can do it yourself. So let's, for example, start with placing the elements for this crossroad traffic lights. So when we are placing the corners here, we can also use a transform points and then a static mesh spawner. And to this static mesh spawner, the mesh entry will be this. Let me just rearrange the window a bit to see more here. So I will create this static mesh here. So we'll be placing the pole for this traffic light into every corner. So let's offset by 200 units, actually 300 units, maybe more, 350. Okay, now I have a traffic light to this side. So after the static mesh spawner, let's do another transform points and a static mesh spawner. And this static mesh spawner will have a mesh entry, which will be the actual traffic light. And let me move it. 425 seems okay. And let's rotate it 90 degrees. So now it's properly facing the sidewalk here. Let's now have the same but for the other side. So let's do another transform points. Here, these transform points, let's connect it to the static mesh spawner and move it 350 in the Y direction, and then rotate it 90 degrees. Okay, now we have the same for the other side of the road. So we have traffic lights to this side and to this side. So in that way, you can see that placing from the corners is easy. Just use the output here from the 4 points use transform points to place your objects where you want. And for the other type of objects, for example, let's say we want to place this grass objects alongside the building. So what you have here is the two splines that are generating the points. We use two splines because we need to have different sizes of elements and we need to have exact placement for each of them. So to place some other objects along every side of this sidewalk, we just can create a single create spline node like we had in the beginning. It should be a linear and closed loop. And after this, we can create a spline sampler. This spline sampler will use distance, let's say 50 centimeters, and we'll do a transform points attribute, and these transform points will connect to a static mesh spawner. Let's connect into the static mesh spawner mesh entry the single grass element that we have. So now just make sure, if you don't get anything in your scene, that you have this spline sampler set to unbounded. And now you can see I have a grass element every 50 centimeters. It doesn't look right. They're all the same. So let's select the transform points. Let's do a rotation maximum 360. Now it's a little bit more random. Let's get a scale minimum of 0.5, scale maximum 1.5. And now you can see we are getting more rotation. Let's do an offset, for example, between -20 and 20 to each side. So now you have places that don't have a lot of grass and some places that you have clusters. Now you can add offset to the other side, -20 as well. So now some of the grass is next to the wall, some of it is more inside the sidewalk. And now, instead of having it everywhere on the sidewalk, let's add after the sampler attribute noise. Actually, let's do a density noise. Density noise and then a density filter. Let's disconnect and connect here. So now this attribute noise is setting a random value from 0 to 1 to each element, and then this density filter is filtering only the values between 0.5 and 1. If you want less of this grass, you can reduce the range this filter. So now it seems fine for me. Let's do a 0.5 to 0.7. Now, in the same way, you can use this spline to place other type of objects. So do a new spline sampler. I'll copy this one. So I have the unbounded box already checked, the distance set. So let's copy, connect this, then do a transform points, then do a static mesh spawner. Okay, so for this spawner, let's do a mesh entry. This mesh entry will be our planter. So now let's use the transform point. First, let's select the sampler and use a bigger value. So for example, 1000 units away, so 10 meters away, we'll have this planter. Next, we'll transform it. So minus 300 units. So it's, let's change it, minus 275. Okay. And into this planter, after you spawn this mesh, let's do another transform points, another static mesh spawner, and into this static mesh spawner, let's do another element. So this will be our tree. Let's select the transform points. And now all the trees look exactly the same. So let's add a bit of randomness by giving it 360 rotation, max rotation. So from 0 to 360, and scale from 0.6 to 1.4, for example. Now you have a little bit of randomized tree looking objects. So you can also add additional element here and connect the other tree. So now you have even more randomization. So you have two different type of trees with the randomized values. This way you can continue adding more elements into the sidewalk. So there are some different types that you can create. I'll not cover everything that is using the same logic, but one additional type of logic that you can implement is, for example, for the bike stands that I had before. So let's do another spline sampler. So this spline sampler, let's say we'll have a bike stand. Let's do it unbounded, and then the distance, and every 8 meters, for example, we'll have a bike stand. Let's do a transform points. Let's do a static mesh spawner. And let's do for the mesh entry this bike stand. So now let's use the transform point. Let's move it some units up, so it's too much. 14. Okay, 14 is fine. Units up. Now we need to rotate it 90 degrees, and we need to move it, for example, minus 65 maybe. Okay, like this. So the problem is now, first of all, you have only one bike stand. So to fix this, usually you have a couple next to each other. So you have these points from the sampler. What you need to do is right click here and create points grid. So this points grid will have the size of the grid, for example, 160 units, 160. And here we'll add 1 for the Y and the Z direction. And the cell size, this will be the size that you want between your bike stands. So let's do 20 units into X direction. So after you create this grid, let's copy the points. So create a copy points. This will be the source, the grid of points that we create, and we'll copy them to the target points that we are currently using to place this bike stand. So let's disconnect and connect these copy points here. So now you can see that instead of creating just one bike stand, we are creating a lot of them. So let's change this cell size of the grid to a bigger value. So 30 units away, I believe, is enough to fix a bike. So let's do a little bit less for the grid extend. So 90 units for the grid extends and 30 units between each element. I think now it looks fine. So what if you don't want to have every 80 units, I mean 8 meters this bike stands? You want some kind of randomization. They're not like the planters, they just need to be somewhere, so it looks a little bit more natural. So you can do like we did for the grass. You can add an attribute noise and a density filter. So I'll copy those two elements, and here I'll connect them before the copy points. So we are filtering the points before we copy this grid to them. So let's change the density filter, let's say for 0.4 to 0.7. So now you can see I have one bike stand here on this side and I have two bike stands here on this side. They are not constantly placing along the full size of the sidewalk. If I debug this node here, let's change it to absolute. You can see I have a lot more points here into the attribute noise, but then when I filter only the ones with values between 0.4 or 0.7, we are just leaving these 3 points, and this will be randomized each time you place the blueprint in your scene. Okay, so let's continue with another type of placement that I'll show you, and you can use to place a lot of decals that way. So let's do a new spline sampler. Let's again make it unbounded and distance, and let's say the distance will be 300. We'll again use a filter, density filter, noise in the filter. Let's do 0.3 to 0.6 or something like this. And let's do a transform points. And these transform points connect to a spawn actor instead of the static mesh spawner. So this spawn actor you can use to place decals in your scene. Select this spawn actor, change this to option to no merging, because otherwise you cannot edit the PCG actor template. You can change to merge PCG only as well, but it should not be a collapse actor. So let's do a merge PCG only for now. Let's change the template actor class to decal. So decal actor. Let's allow the actor template editing, and let's open here this decal section. So this decal material, you can download a decal material from Quixel. So let me open my Megascans folder, the decals folder, and I have this concrete crack, for example. So let's connect this concrete crack here. Now this concrete crack has dimensions of 2000 by 500, so it's 4 times wider than it is longer. So here into the decal actor, the decal size, you need to have one of the elements 4 times the other. So if one is 128, this one is the wrong one, so this one needs to be bigger. This is the width, so let's do a 256 for this one and 64 for this one. And this is the proper ratio for this crack. So let's use these transform points to move it a little bit more in the middle of the sidewalk. So you can see now here, this crack is moved in the middle of the sidewalk. We can add a random rotation between 0 and 360. We can add a random scale between 0.5 and, for example, 2. So we have bigger cracks. 2 is too much, so 1.5. So we have bigger cracks and smaller cracks into our sidewalk. This spawn actor as well here into the decal section. It has a very big value here into the vertical directions for the decal, which will be a problem when you have the wall of the building here. The decal will spawn alongside this wall as well, and it will look like a bug. So let's change the decal size from the vertical to some smaller number, for example 5 centimeters. And now we need to move the decal to better match the position here on the sidewalk. So 10 units up. So now it will only be applied here into the area of the sidewalk. It's a little bit too bright. So let's go inside the material and change it a bit. So here I will do a color overlay and I'll give it a darker color. Let's save it. Let's find it somewhere else to see if it looks good on all the places. Okay, it looks fine, I believe. So you can have these big cracks on your sidewalk, and to get more randomization, you can add more elements like this. So using this spline sampler, let's do the distance increment a little bit smaller. So let's do 50 units away. This way there will be a lot more points to use. We are adding a noise, and then here with this density filter, now I have too much of these cracks. So let's reduce the range to 0.3 to 0.4, for example. Now I will have places that the cracks are close to each other, or other places that I have no cracks, but you can add more randomization now by adding more elements, by copying this density filter, transform points and spawn actor, changing the density filter values and changing the decal here. So I can have this another crack here, or for example I can have debris like this garbage pile or this garbage elements. So now you just need to fix the size here, because this garbage element is a square texture. So into the decal size, you need to make sure that these two values are equal to each other, because this is a 2000 by 2000 texture, so it's a square aspect ratio. Also, these transform points, because these are like cigarette butts and some other stuff, we cannot have such big randomization of the size. They need to be closer size to each other in order to look more realistic. So let's do a 0.6 to 0.8. For some reason, if I have it 0.6 to 0.8, it doesn't work. 0.6 to 0.9 works fine. Let's use this. Okay. So I have this garbage packs they're adding a little bit of randomization to my sidewalk look. You can place other type of decals alongside by copying and editing the filter. You can use this trick with creating the point grid in order to place repetition of objects. For example, that way I have created a grid and placed these grasses around the planters here by creating a point grid around this point where I have the planter. So you can continue adding additional details. The same way that we added the planter, you can add the street lamps. So add a distance and place them alongside. You can even use these splines that you generated here to add elements only on one of the sides, because one of the splines is responsible for the long side and the other one for the short side. For example, if I want on the short side to have boards to not be able to park on the sidewalk, let's disconnect this to check. Okay, this one is the short side. So let's use this create spline. Let's do a spline sampler. So we are sampling the splines along the short side. Let's check the unbounded, the distance, and let's say, okay, 100 seems fine. We'll do a transform points, and then we'll do a static mesh spawner. This static mesh spawner will spawn this metal board, add a mesh entry, and into the descriptor connect this, and now use the transform points to place them. Let's scroll and place them. 400 is too much, so minus 375. Okay. Your problem is that they are interfering with this element at the end. So you can either filter the first and the last, or I'll just move them for now. Minus 385. In that way, they're a little bit away. They are in the center of this curve element. So let's say that way. So you can see that you can have them. Let's rotate them as well. So let's do a random rotation between 0 and 360. So now it's a little bit more randomized look. So you can see you can have different type of elements on the front side and on the short side. For example, if you have a big boulevard here and small connecting streets between them, you can have different type of elements on any of them. You can have the bike stands, for example, only on the one of the sides, and you can think of any logic to place your objects and use the methods that I showed here. Let's do 150. I have too much of this. Okay. Now it looks better. You can continue adding elements in the same way to achieve a more detailed look, but for now I think this is looking great. The next step will be to connect this to the building PCG graph or some other PCG graph that you want to use to generate this alongside some other object. So we need to have everything here as a subgraph. So let's zoom out, let's select everything, and let's right click and collapse into a subgraph. So let's go into the PCG sidewalk folder and let's save this as a PCG subgraph sidewalk generation. Okay, so now my PCG blueprint contains only this create points and this PCG subgraph. This subgraph node you can use anywhere you want to generate this sidewalk. So if I go to my building PCG graph, so let's delete this for now. Let's delete all the decal actors that we placed as well. They're left in the scene when you delete the blueprint. Otherwise, if you just regenerate it, it's automatically deleting them and generating new ones. But if you delete the object, you need to delete the decals as well. So now, if I go and place the PCG building, let me go to my PCG building graph. So now let's change this wall ceiling height to 300. Okay. Now let's change the length. Okay. So now I have this building connected to the PCG graph that I created before the tutorial. So now let's go into the PCG building and let's open the graph. So here, where I have the sidewalk graph connected, let me delete and disconnect it. Now I don't have any sidewalk currently, so let's go into the new PCG graph that we created, so the PCG subgraph for the sidewalk. Let's create the subgraph node and let's connect it here. So now this new subgraph is using the 4 points of my building corners, and it's generating the new PCG graph that we created in this tutorial. So you can see we have the elements on one of the sides, the different type of elements on the other. Everything is like we set up, but we have this problem that this building is not exactly some multiple of the size of the sidewalk length. So we need to create a way to connect this better so we don't have a gap on each of the sides. And other thing to note here is that if you don't make sure that your points are sorted in the exact same way that you had into the create points node before, you will have a problem where your sidewalk will go along the diagonal sides or something like this. So let me show you. So here, let me disconnect everything into my PCG building. Let's say like this. So now you cannot see the building. I disconnected everything. I'm just using these single floor points where it exports the corner. I'm merging the corners. I'm transforming them because they are not originally on the corner. I'm sorting them, which is the important part to have this generation working fine. If I don't sort them, let's disconnect here. You can see that they're in the wrong order. So my PCG graph is not generated properly. So I need to sort them based on some criteria. And you can see that the criteria I'm using is this custom attribute corner index. This corner index is an attribute that I set up here into my single floor graph. Actually not the split single floor points, but the generation of the single floor points. So here into this generation of the single floor. So here I have a logic that creates this custom attribute. So let me show you what's the logic and why it's implemented that way. So let's inspect this intersection node. If you don't have this building generator, you can check my previous tutorials. But this intersection node is basically creating two of the corners. Let's say this diagonal here, this right one and the left one. Let's do an absolute debug node here. Let's do a 3. The important thing is that it's creating two corners that are opposite to each other. And the same is for the other node here. Let's do absolute 3, 5. Okay, so these two intersections are creating the corners, but they are creating them in a way that they are not exactly one after another. They are with one corner between them. So they are the diagonal pieces. So after one of the intersections, I am using this copy attribute to copy the index into the corner index. So the index of these 2 points will be 1 and 0. And if I have two of the points with index 0 and 1, I need them to be next to each other. So what I need to change here is to have the diagonal points 0 and 2. The points will be 0 for this first one. So this should be 0. This should be 1. This should be 2. So if I have my two diagonal points, this is 0 and currently this is 1, I need to multiply by 2. So because this is 0, if I multiply it by 2, it will become 0 again. And if this is 1, if I multiply it by 2, it will become 2. So I'm using this multiply. After I copy the index attribute into the corner index, here this multiply is using this, let's say, corner index. It's using this corner index to multiply by 2 and outputting the result into the corner index. Then the other intersection, I have these other two elements. So I'm copying the index into the corner index. So they are again with indexes 0 and 1. And now I need to have the indexes to be 1 and 3. So the two remaining indexes. I'm multiplying by 2 again. The result is corner index 0 and 2. Then I'm adding 1. So here I'm multiplying the corner index by 2. Then I'm adding the corner index to this new attribute, which is 1. And after this add node, if I scroll at the end here, you'll see that the corner index for these 2 points is 1 and 3. And for these 2 points, the previous one is 0 and 2. So I have 0, here 1, here again back 2, and here to the next one 3. So I have the same corner index elements as I had into the create point, but now instead of the index, they are in this custom corner index attribute. I'm then merging them. I have this 0, 2, 1, and 3. They are not aligned here. That's why here into my PCG building, where I use these corners, I am sorting them on this corner index attribute. If I inspect this split single floor points element, if I select my blueprint here, you can see these are the 4 points that are coming here, index 0, 1, 2, 3, and the corner index 0, 2, 1, 3. I need to align them based on this corner index instead of the original index. So that's why I'm sorting them in an ascending order with the corner index. And this transform points is used because originally these points are not on the corner of the building. So let's go back here, stop the debug of this. Let's go back to the building and debug these transform points. So originally these points are coming like this. So they are connect everything. So my floor is, so you can see here the point where I have this. Let me scale the debug option. So I have the absolutes. Let's do it like this. So this single point where I have this blue line, it's not aligned with the corner of the building because I'm starting to place the walls here from this point to the side. You can see the wall is starting here. This is the corner piece. So that's why I have these transform points before that to move 75 units. And that way I can see that the point is now matching with the corner, this blue line. Let me scale a little bit more this point scale. So now this is matching exactly with the corner. So in this way, check your PCG graph. If you're not using this building or something else, make sure that the corner points that you're using to generate this sidewalk are aligned with the corners of the element that you want. This is what this transform point is doing. So moving them 75 units to match the corner of the building. Then I'm sorting them based on the corner index. If I don't sort them, I showed you there is a problem with the order and I have these diagonal pieces of the sidewalk connecting wrong elements. That's why I sort and then use this graph. How you can fix this problem with the gap at the end of the sidewalk? So let me explain what the problem is. So let's use the best tool for explaining, Paint. Here you have some number of segments of the wall. Let's say the wall is 8 units wide. Let's say your building is 3 walls wide. And then you have a corner element here, which is some additional value, B. And you are placing sidewalk elements like this, which are not the same size as the wall, neither they are the same size of this additional element B. So you have never the overlap of the sidewalk element here and the size of your building walls and the corner at the end. So you need to calculate the size of this full wall with the number of segments of the wall plus the end corner here. Then calculate how much of this sidewalk elements you can place here and the additional space that you left behind that you currently can see here into the scene as a gap. Then use this number here and scale each of these pieces with the small amount that you need to fill this gap here. So for example, now I have 1, 2, 3, 4, 5, 6, 7, 8 pieces of the sidewalk. This gap at the end, I'll divide it by 8. So let's say this gap is x units wide. I'll divide it by the 8 units that I have, and if each unit is, for example, z units wide, z plus this x over 8 will be the full final size of this pieces. So each will be z and then 1/8 of x. In that way, at the end, they will match perfectly with the size of your wall. So how you can implement this into your PCG graph? So first of all, you need a couple of inputs into your PCG graph. Go into the PCG graph subgraph that we created, click on this input field. We are currently using this out pin, as you can see. Let's call it corners. The type is point, this is fine, okay. So this in pin we are not using, let's delete it. And let's add 3 other pins. So the first pin, let it be width. This is the width of the building. The type will be attribute set. Will not allow multiple connection and will not allow multiple data. It will be a single element. So the next one will be length. It will again be attribute set and no multiple data. The last one will be our wall size. It will be again an attribute set and just a single element. Let's start with multiplying the width with the wall size. And because we will have other calculations as well, and we will do it with the length as well. So let's make this into a subgraph. It cannot do it when it's a one node, apparently. So let's connect it to add node. Let's select both of them and now collapse into a subgraph. Go into the sidewalk folder and make it a PCG subgraph sidewalk segment. Now it has 2 inputs. Let's go inside this subgraph. Let's select the input node. Here you can see this input is not being used, so we'll delete it. This width will name number of segments, and the wall size will be mesh length, for example. So this we'll use 2 times, once with the width and once with the length. So let's create an attribute. This will be our sidewalk segment actual mesh length. So let's drag out of this and add a name tree route. Click F2 to rename it. And let's name it sidewalk length. And our length is 200 units. So let's enter the double value of 200 units here into this create attribute that's creating the sidewalk length. We'll then create one other attribute here. Create attribute. It will be 75. This is, if you remember this drawing, this is the amount that we need to add for the angle at the end of the building, this B segment. let's currently have it as fixed as 75. You can have it as an input or some property in your blueprint, but for now let's use 75. And we'll add multiplication of the number of segments. So this number of A segments in this drawing, it is 3 multiplied by the length of each segment, and then we'll add the length of this B segment. So this is what this add node is doing, adding the size of the wall by the times the wall is repeating and adding the last element here. We will divide this by the sidewalk length that we have here on top. So let's use the name tree route by right-clicking, choosing the name tree route and the sidewalk length. So we'll divide this and then we'll for the result from this division. Because in my example here, I had 8 times this segment and the last time it's not full. So for example, you will get 8.3 and this 4 will take only the full number, so 8 segments. And then let's get a modulo operator. This modulo operator will again use this sidewalk length, and this will give us the remainder of these divisions. So this 0.3 of the element that is left in the example of 8.3, this 0.3 element is with some size, for example, 0.3 from 200, it's 60 units. So this will be 60 units as a remainder from this division. Then we'll divide these units by the number of segments that we will have as a sidewalk. Like I said here, we'll divide this X segment by the number of resulting segments, so X divided by 8 here in this example. That's why we are dividing this length here by the number of segments from our floor operator. And then we will get the original sidewalk length and we'll add this 1/8 of the remainder here to each sidewalk length element. Then, as a quick fix, I have implemented one additional operator here, because sometimes, because of the rounding of the numbers and the way that Unreal calculates the operators, the math operators, you'll be left with just a little bit longer segment than needed. So we'll actually subtract here just a very small amount, create attribute again, and we'll subtract 0.01, so 0.01, very small amount, just to be sure that our element is not overlapping the end of the spline that we have. And this result will add a name tree route again, name tree route declaration node, and click F2 to rename it and rename it to result length. Okay, so this is our result length. The other things that we need to output from this, let's get here this output node and bring it down here. So let's delete first this pin that we are not using. Let's add one pin and make it a attribute set. And let's call this result length. Let's use our name tree route for the result length and connect it here. So the result of our calculation will output from this subgraph in the result length pin. We'll have two other pins. One will be the translate offset, and the other will be the scale value. Let's change them to an attribute set type, not allowing multiple data. Okay, now they're fine. So what we'll need this translate, offset, and scale for. If we go back to our subgraph for the generation of the sidewalk, you can see here where we are outputting our points for placing the sidewalk segments and the curb segments. We are offsetting by 100 units in the X direction. This 100 units is actually half the size of our segment, but here into our new calculation of the size of the segment, it will calculate a different size. It will add this additional number that we need for each segment. So we will get this result length named reroute. It will divide this by create attribute. This attribute will give it a value of 2. So we'll get half of the length. Then we'll make a vector. So make vector attribute. This vector will be of type vector, so with 3 values. We'll create an attribute, which will be minus 385, which is the value that we are offsetting here into the Y direction. And for the Z direction, we are using for the curbs and 14 for the sidewalk. So how can we use the same for both? Let's use the same points here. So let's delete this one. So after we use both of the splines into these transform points, then we will do a transform points just here for the segment, and we'll offset it here by 12. I believe it was the value before. So let me check if they are connecting properly. Okay, it seems no, it's too low. So 13, 14. Okay, 14 looks fine. Okay, great. So now we are having this vector. The vector that the value that we need for the Z is 0, so we can leave it not connected, or we can create attribute and have a value of 0. So this vector is our translate offset. And to calculate the scale, because as you remember from this perfect drawing here, all of these segments needs to be a little bit longer, so we'll scale them a bit up into the X direction in order to cover more area than they're originally covering, and in that way at the end it will match perfectly with the length of the wall. So to calculate the scale, we'll get the result length, we'll get the sidewalk length, we'll divide the result length with the sidewalk length, and then we'll make a vector attribute, again type vector, and this both y and z values will have a value of 1, so we'll create this attribute with a value of 1, connect it to both of them, and connect the scale output here. So let's save this subgraph. Let's go back here into our main graph for this sidewalk. Let's save this as well. So here, the result length will be used here into the spline samples that are using for now this distance increment of 200. We are placing both the curbs and the sidewalk segments based on this value of 200. But let me move everything here a little bit down. So now let's open this spline sampler and let's connect this result length into the distance increment. So it will not be 200, it will be the calculated value that we have from this subgraph. Oops, sorry. Let's go back here. Okay, and the translation offset, we need to use it here into these transform points. So let's drag out of here, add reroute node, and let's connect this to the offset min and offset max. And let's do the same with the scale. So drag out, add a reroute node, and connect this to the scale min and scale max. So these are the values for one of the sides. So let's go here and check the result. There is no change, so let me check if everything is connected. So we have connected the number of segments and the mesh length. We don't have the connections in our main graph. So let's save this. Let's go into the PCG building. You can see nothing is connected here into our inputs. So into the PCG building, let's use our attributes that we are setting in the blueprint. So we need the width, the length, and we need this cell size calculated value. So I'll copy the width and the length here. These are get actor property, the width and the length. We'll connect them both here. And we'll use the named reroute for the cell size that we calculated here into this blueprint. Actually, sorry, this PCG graph. So let's save this. And now let's look at this PCG graph. So now you can see we are properly connecting everything at one of the sides. The other side is still not done here. It's not connecting. So let's go back into our generation subgraph. Let's copy this subgraph that we created now. Here, where we are sampling the spline for the placement of the other two sides, we'll connect the length for the number of segments and again the cell size for the mesh length. We'll connect the result length to the distance increment of this node. We'll connect the translate offset. Actually, we'll need another transform here, so do another separate transform points here. And let's connect to these transform points the translation offset, add a reroute, connect it to the offset min and max, and then add a reroute for the scale, connect it to the scale min and scale max. And now let's merge these points from the two elements. Now let's use one of them to place the curves and to place the segments. So now I have all the sides properly connected and generated alongside the building with this new subgraph. And if I change the values for the size of my building, so I have 4 elements in width and let's say 10 elements in the other direction, every time my sidewalk is generated properly alongside the building. So let's connect back again into the PCG building graph the other floors, because I have disconnected them to see better the generation of the sidewalk. Let's connect this outside filter, or it was not this, sorry, this outside filter here. Okay, so now I have my full building generated. It's being controlled by my values here, and the sidewalk is generated alongside the building. Everything is dynamic and controlled by the blueprint variables. This way is very easily usable to generate a lot of different type of content for your level. For example, I want a building that's bigger, I want to have the roof windows, I want to have it 1 floor less, I want to have some blocked windows, let's say like this. So I have now 2 completely different buildings with the sidewalk automatically generating different kind of details alongside each of these buildings with the values that I have entered as variables. So hopefully this helped you to understand how you can add additional subgraphs and use them with the generation of the spline based on your PCG points. In that way you don't need to draw the spline yourself, you can generate it from points that you already have in your level, and in this way it will be dynamically placing the sidewalk in your level. You'll not have to separately do a building and then a sidewalk PCG graph with drawing a spline. It will automatically generate the spline and place the objects alongside. If you like this, please like and subscribe, and if you have any questions, write in the comments. If you have suggestions for other tutorials, again, write in the comments. If you want to support me, please join the channel. You have some additional perks there, you can check them, and I'll see you in the next one. Bye guys!